Good-looking guy. Even with complete mastery over the sea, Aquaman will never see all of the sea. And I know that's kind of a weird statement to make, but follow me here. The ocean covers most of the Earth's surface, and so that surface area is substantial, 360 million square kilometers. So let's say that Aquaman wanted to, survey all of his domain and see every square meter of the ocean's surface, whether it be the surface itself or the floor. In the previous episode, the last episode of Because Science, we stated that Aquaman can travel at 3,000 meters per second. So as a first approximation, let's say that Aquaman could see about a meter on either side of him, just kind of shoulder width, and he was traveling at 3,000 meters per second. That creates a kind of rectangle that says he can look at 3,000 square meters of ocean surface every second. If we divide these values, the amount of time it would take for Aquaman to survey all of the sea, all of his domain, would be over 3,800 years. So if he has an average human lifetime, not going to work. What if we bump this up from 3,000 square meters per second to 10,000 square meters per second? Well, even then, if we do that, this value is over 1,000 years. If we bump this up to 100,000 square meters, this goes down, again, as you may guess, to over 100 years. Still not quite going to work. Only when we bump this all the way up to 1 square kilometer per second do we get a reasonable value of around 11 years if Aquaman was trying to survey the whole ocean. However, there is a physics limit here. In the best, clearest water, because of the way wavelengths of light travel through water, the best visibility you can hope for is around 80 meters or so, I researched. And if it's only 80 meters, let's assume that Aquaman can see 80 meters on either side of him and 80 meters in front of him to create a kind of square for our square meterage here. And if you do that, the value is still 890 years to survey every square meter of the ocean. So though he is strong, though he is fast, though he has complete mastery over the seas, Aquaman can never see all of the sea. Seems kind of pointless. But hey, this is the live edition of Because Science. It's Because Science Live, the live show where I take all of your comments, questions, and corrections with markers and address them. And hopefully I can say something coherent and intelligent in real time off the top of my head. If I cannot, I'll say I don't know it. But I know a little bit about a lot of nerdy stuff, so consider me your conduit to this sciencey, pop culture-y universe. I have Nate here, who will be taking your questions in the chat. Nate?
Yep.
Nate!
Yeah.
What do we got?
From 360 Glaze It.
The coolest donut shop in town.
Do you get nervous before shows? What's a scientific way to feel less nervous?
Oh, I wish I knew a scientific way to feel less nervous. Yeah, this live stream, honestly, if I had to be honest with you, is the hardest thing I do all week. And I still get monumentally nervous to the point where you're so nervous you feel like you have to pee constantly, even if you do. And it's just very hard to try to entertain you and to be interesting and accurate, scientifically speaking, off the top of my head for 30 minutes straight without stopping for even 10 seconds. So that's still very stressful, and I get very stressed out. In terms of ways to calm yourself down, I haven't really settled upon a good method, whether that be deep breathing or drinking a lot of water or just trying to calm yourself down. Usually for me, there's a introductory period, if you will, where once I start, I'm really nervous, but after a few minutes, I start to feel it out and I feel better and more comfortable. So I'm sorry I can't offer you any expert advice, but I feel like it would vary very much from person to person. What's next? Oh, I'm so nervous. I just want to be good.
From Chaos Genie.
Ooh, don't rub them.
In the comics, Batman has stayed up for 80 hours straight on the job.
80 hours?
Yeah, apparently.
Well, apparently.
Is it humanly possible for Bruce Wayne to power through the effects of sleep deprivation and still be a good crime fighter?
Are you sleep deprived, Nate?
A little bit.
A little bit. I don't know how what Batman could do to specifically fight sleep deprivation. However, I know of some general values. So 80 hours is a lot, but that is what? That's less than 5 days, correct? It's less than 4 days. 4 days is around, 96 hours or so. So 4 days, he's up for a little bit less than 4 days. Now, the general value that I've heard, well, I guess it's not a limit, but I have seen reports of people dying after like 10 days of not sleeping. And it's weird because we don't really think of sleep as something that we need to live, like water or food, but sleep is when kind of like when the brain compiles everything that it's learned for the day, and your body goes into kind of a rejuvenation period where it's cleaning up things and stuff because you're not, having to move around and all that stuff. And it feels like you're dead, but you don't know. So sleep is very, very important. And so about 10 days, I think, is nearing that limit. Like you'd have a limit for food or for water. I know a kid who is up for 11 days or something playing video games, and he just died at his desk. So Batman could probably stay up for, 4 days or so if he really was trying to push himself, and, it's Bruce Wayne. Just imagine the kinds of expensive alertness drugs he has. Super meth. What's next?
From Lady Farron.
Don't try super meth. Yeah.
From Lady Farron, is there a way life could exist that wasn't carbon-based or need water to survive?
There was a big... Well, I don't want to confuse anybody, but I remember a couple years ago there was a big hullabaloo, which is a word people still say, about life kind of subsisting on arsenic in a pool of like very acidic water. It was some microbes in some kind of thing. Anyway, why carbon is so likely to be associated with life, or why it creates so many different chemicals and compounds for our lives, is because carbon has the ability to form 4 bonds with different atoms and molecules. It's very versatile, and so there are thousands of different chemicals that are associated with carbon. That's what we call organic, and there are many, many organic things. As you know, you are one of them. When we say, can life be different than this? Some people say silicon-based life, because it can also form many bonds with other adjoining atoms and molecules. But as to whether that's possible, we just don't know. We have a data point for life on Earth, which all evolved from a single common ancestor billions of years ago. We only have a data point of 1. This grand experiment that is life on Earth and evolution has only happened once, as far as we know. And so we don't really have any other points of comparison, any other data points to say, if we find life on Europa or something like that, and it's silicon-based, then you can say, certainly seems like it's possible. Let's investigate this further, and what other life may be in our oceans, or extremophiles living in the most extreme environments on Earth. Maybe they could have similar properties because they were evolved in similar conditions. But it's very, very hard to say. Theoretically possible is different than practically possible. It depends a lot on the environment that something evolves in. We are the product of what Earth is and the environment is. We wouldn't be shaped the way we are. We wouldn't reproduce or eat the way we do without having the same environmental pressures that are on Earth, the gravity and the chemicals and stuff. So, no idea. I do not know. I know it's batted around a lot by science fiction authors and stuff like that. But silicon-based life, although it can form many bonds, we don't have any data points to say if it is practically possible or has happened or will happen. What's next?
From Scott F.
Hello.
If you could be any superhero/villain, who would you be and why?
If we had any superhero. So I do... As some of you may know, I often say which superpowers you probably don't want if you think about them scientifically. And what I keep going back to are the superheroes that are just extreme versions of the human condition, things that are within a few standard deviations of average. And when I say that, I mean, you're very, very smart, but you're not superhumanly smart. You're very strong, but you're not superhumanly strong. You're still within the bounds of humans. And the superheroes that do that are the heroes like Batman and Iron Man. And what I like about Iron Man specifically is that he is just a guy. He is a very, very intelligent engineer and scientist who is able to augment his human shortcomings to give him, superhuman durability with a suit and flight and things like that. But at his core, he is just very intelligent, and he knows how to work through problems. And he has a lot of personal problems of his own, and he deals with that. He feels more human than some of these characters do. My vote is usually for Iron Man because he feels like he is just a man who has mastered his craft, and it's believable. And then Batman, I think, is very close to that because if you are in the peak if you are the perfect genetic specimen, you are in peak condition, have the best training, have billions of dollars at your disposal. A lot of the things that Batman does, they don't seem that far-fetched. So that would be my answer. What's next?
From Anthony Davidson.
Oh, hello, Anthony.
What actually moves when electricity flows through wires?
Electrons move. Electrons move, and they can move they're moving so quickly that it's like speed of light transmission, or it could be based on the conductor that it's going through. And so electrons move very, very, very quickly through something like a perfect conductor, like a superconductor. So it's the electrons that are moving around or transmitting the charge, so to speak. And I'm thinking about life again, and all of life kind of is the transfer of electrons, is the movement of electrons as atoms bind to other atoms. They form bonds, which is either donating or receiving an electron or sharing electrons, like in a covalent bond. All of that is the basis for all of your chemistry. Everything that is you, all the bonds that make you up, it's all about how electrons are interacting with each other. Life is the transmission of electrons into this, kind of. What's next?
From Aaron Yu.
I think electrons move at the speed of light through a wire. Whatever. That explanation wasn't as technical as I wanted it to be, but it can feel that effect. It's the electrons that are transmitting the electricity. Sorry.
From Aaron Yu.
Hello.
Can we walk over plasma?
No. So I think I think maybe what you're thinking about is something like a lightsaber. And if we think about what a lightsaber is, what I always say a lightsaber is a perfectly cylindrical, of course, perfectly cylindrical tube of very, very hot plasma. Now, what Star Wars wants you to think is that this plasma, when interacting with another tube of plasma, that these would interact and stop each other and kind of be like solid, like you're just hitting two sticks together. But what plasma is, the fourth state of matter, is basically very, very, very hot gas. And very, very, very hot gas is gas that is so energetic that electrons have been ripped from it and they're just kind of floating around in it. And because we just said electrons can transmit electricity, plasma is receptive to electric and magnetic fields. But plasma is still a not very dense thing. If you think of going from solid, it's on the top of the scale: solid, liquid, gas, plasma. It gets very wispy, or it can. So to have something dense enough to stand on, I don't know if you could really call that a plasma anymore. Well, I'll say this: if a plasma was packed tight enough that it was solid enough to stand on, it'd kill you. Probably, it would be so energetic. It'd be like trying to stand on the sun, which wouldn't really work, would it? No. But plasma, as you've seen it in like blaster bolts or a lightsaber or something like that, would not be dense enough to stand on. It'd be like a gas, I'd say. Whew, these are toughies. I hope I'm getting them right. What's next?
From Reed Williams.
Hello.
How long does a typical episode take just to research?
So because I love myself, I have created a system where I am constantly researching and writing without stopping ever. So for the typical Because Science episode, This is my day job. So it's 9 to 5, working, researching, performing, writing, doing this kind of thing. And I'd say the average episode, now that they're around 10 to 15 minutes, takes 1 to 2 days of research, and then it takes 2 to 3 days to write the script the way I want it, and then it takes about half of a full work day to film the episode. It takes me around now, man, what is it? About an hour to film 5 minutes worth of content after it's edited down, so it's quite a bit. So it takes me a full work week to get one episode researched, written, and filmed. A full week per episode. If I could do more at the same level of quality, I would, but we have to do footnotes and we have to do these live streams. So that's what I wanted to do. So I enjoy the level that they're at, but I have almost no time to not do this at all. It takes a lot, and I hope that shows sometimes. What's next?
From Sean Greer.
Hello.
Can you give yourself a concussion if you sneezed hard enough?
What? Can you give yourself a concussion if you sneezed hard enough? So I see a couple interpretations of this. You're making me sniffly. Okay, so let's consider the weirdest scenario. Could you sneeze hard enough that you eject some amount of gas and fluid out of your face so quickly that it throws your head backwards enough to give you a concussion? I do not think so. You're just not sneezing quickly enough, and enough mass isn't coming out of your face enough to turn your head into a small rocket. That's probably not going to happen. I think what you mean is if you just naturally sneeze and have and just throw your head back because that's the motion that you make, or forward, throw your head forward, and that's the motion that you make. Could you give yourself a concussion? I don't know. I'd say probably not. The kind of forces you need, the kind of accelerations that you need to give yourself a concussion, we know what kind of forces that takes. It's like being hit in the head on a football field if you're a linebacker or whatever. It's like running into another person at 10 miles an hour or something like that and hitting your heads together. I do not think the physiological response of sneezing is anywhere near that kind of acceleration. I think if anything, you just get a little bit of whiplash in your neck if it was really, really bad and you're sneezing all the time. But for a concussion, I think you're probably well below the acceleration for that. I don't know what concussion acceleration starts at, but if it's in the tens of G's, 20 to 100, then I don't think you're sneezing. I don't think you're sneezing that much. And if you are, you need to rethink how you're. Maybe just hold your head with each hand, just like that. That might work. What's next? Could you sneeze into a concussion? Wow, what a terrible superpower that would be. Well, I can sneeze with the force of a hurricane, but I knock myself out constantly.
From Nikki Willis.
Hello, Nikki.
So, what was with all the spaghetti references in the Speed episode?
I like the spaghetti meme. Touch my spaghetti. I like that one. That was funny. But what I was referencing was an article. I think it was an article by The Onion, which is always hilarious. And I think it was a review of the show The Flash on the CW, which many of you probably watch. And the title of the article was if the Flash is supposed to be scientifically accurate, why doesn't he run to Italy for every meal? And the whole article is just like, sure, they talk about vibrations and speed and light, but, if they really want to be correct, why doesn't he run to Italy for pasta for every meal? That's ridiculous that he doesn't do that. So I really thought that article was funny. You could probably look it up now. And that's where the spaghetti comes from. And I love me some pasta because I like to carbo load sometimes. Nate, help me out of this one.
Yeah, I'm here.
Thank you.
From Captain Barbosa.
Oh, the Captain Barbosa. The Captain Barbosa? The guy who's half skeleton, half Jeffrey Rush, and all monkey on his shoulder?
The same.
The very same.
Do you always brush your hair front to back?
I hope you like ghost stories, Miss Turner. You're in one. Remember that? I don't brush my hair. Don't need to. What's next? I actually don't.
From Clive Lockwood.
Clive Lockwood, Private Eye.
Why does a wound from a sharp knife feel less pain and heal quicker?
Yeah, I don't want to speculate where I don't know, but when you get sliced with like a scalpel, if you or you know, most of you probably haven't been sliced with a scalpel. If you've ever been cut with something like an X-Acto knife by accident, it's so sharp that you can be cut without even realizing you're cut until you're like, oh, oh, oh. Like, you know, if you reacted like Robin Williams for some reason. Oh! And even piranhas. It's reported that their teeth are so sharp that when they bite you and take a chunk of flesh out of you, it's so sharp and so quick that you don't even notice that you're missing a chunk of flesh until you look down and you're like, oh! Like that. And cookie cutter sharks, it's the same. That a swimmer was attacked by a cookie cutter shark, and they're named that because they have little circular mouths, and they grab onto you and they take out a cookie cutter shaped chunk out of your body. It's very rare, but the swimmer didn't notice because the teeth are so sharp, and he didn't. And when he came out of the water, he's like, "Oh, there's a cookie out of me." Cookie of flesh. Hashtag cookie of flesh. But I believe this is because the cut is so clean and so efforttle. So to contrast that with something like a paper cut. Now a paper is not. Ooh, I don't want to draw that. That might be dangerous. A paper cut, yes. A paper cut, by contrast, from something like being cut with a scalpel, can be it will leave a very jagged wound. And this jaggedness contributes to how your nerves react and how the skin comes back together. And so it can be a lot more painful, aside from if you were to just make a very clean cut through the skin. And you can imagine the difference here. So I think it is the roughness of the cutting implement that can contribute to its pain. Paper is very jagged. If you look at paper in an electron microscope, or maybe just a very high-powered microscope, you can see that the edges of it are very, very rough. But if you look at something like a scalpel, a razor blade even, razor blades are very, very uniform and still very sharp down at very high magnification. You can look it up and it's really cool. So, jagged, bad, hurts your nerves more so than a nice clean cut would, and that's, you know, that contributes to why you want to use something like a scalpel if you have to cut into somebody, if you're a doctor or something like that. I'm pretty sure that's correct. What's next?
From Kieran.
Kieran.
How long can an ordinary human be able to survive underwater?
How long can an ordinary human survive underwater? There's a couple interpretations of that question. How long could a human stay underwater if they had an oxygen supply? I do not know. You would deal with the problems that Aquaman, that we said Aquaman would have, where, because of osmosis, water would flow out of your body into the surrounding seawater. It would be incredibly cold. You would lose heat at an incredible rate, I think 20 times more, 25 times more than you would in air. And so even with an oxygen supply, you would get very, very cold and very, very dehydrated. And then also, how are you eating? So there wouldn't be, it's not a very extended period of time. Another interpretation would be if you were living underwater in like a lab, then I think it's indefinite if you have the right resources. The other interpretation is like, how long can you hold your breath? And that ranges from, if you or I tried it, a minute or two, to people who have actually, we just discovered that there are people in islanders, I forget where they're from, who have evolved to be better at holding their breath, genetically speaking, and that's a few minutes. And I know now, like how David Blaine does, if you breathe in pure oxygen and saturate your blood with pure oxygen, you can hold your breath for like 10 to 20 minutes, something like that. So how long can a human survive underwater? It is somewhere between indefinitely, if you're in a lab, to probably less than a day if you're just scuba diving naked, to few minutes. That's what I would say. And I'm sorry if I'm not interpreting your question the correct way, but it's not a sustainable thing unless you are not actually in the water, like you're in a sub or something.
One more.
Whew.
From Remo Brown.
Remo.
Just wondering if you have any new maintain tips?
Maintain tips. So I just discovered that hairspray works pretty good. Look at that. Look at that. Look at that. Look at that form. Look at that shape. Look, dudes, we all want long hair. At least once. We want to look like rock stars. But you don't want it always in your face. You don't want it stringy. You don't want it gross looking. Wash your hair. Maintain. Argan oil. Blow dry it backwards. Hairspray it. Then you can look like that guy. And that's all the time. Man, lots of very scientific, hard-hitting questions for this one. And that's all the time we have for this episode of Because Science Live. Thank you so much for joining me. I hope you have a wonderful rest of your week. Before I go, though, many of you probably know a fellow sciencey YouTuber, Simone. You might know her as the queen of crappy robots, so to speak. And she just announced in a video that her brain tumor, which she thought was going to be mostly gone and benign, is now returned, and she has to go into radiation therapy for this to deal with it. And she is one of the most genuine and funny and talented people that I've ever had the pleasure of meeting. So if you want to go and watch her video, there's a link to her Patreon. She will need the support eventually. She has a great support system, but if you feel like contributing or just sending her good thoughts or anything like that, if you enjoy her work, I would do that because she is a very, very kind and interesting person. So with that, like I said, have a wonderful weekend and be nice to each other because this is all we got.